So this is going to be a very short part 2 of the fantastic talking machine. We wanted to check all the power supplies. So we're going to take out the power supplies and bring them to my lab for further investigations. Here I just wanted to document the wires. So this power supplies 24 volts, goes up to this modules, to the PCBs down here and down here. So this, I want to desolder those wires, so that will be the A and the B module power supplies. Ooh, this looks a little bit funny with the diodes. So we got 2 and 2 sets of diodes. That's like in the black wire back to the ground. So this is actually lifting the entire system of the two first of the A and the B modules. We named all the different modules like A, B, C, D, so it's easier to figure out where we are. So this is important. The diodes goes like this. So what I think is we got we got 2 wires here for the next module. So this is using 2 of the power supplies. That is something we need to remember. Are we going to have a very, very short sneak peek of what else is inside the C module? So all those signals you see here, that will be the timing signals of the selected time interval. So this time interval, the selected time interval, goes all up in parallel to all the different variable DC filters. So look at all this. So this takes the analog signals in from the programming modules, you could call them that. So at this time and this time and this time, you will have different filter constants. Of course, if you have a 10 milliseconds or 20 milliseconds and so on, you're going to have different intervals between the analog transitions. So it's going to filter the signal really, really nice and smooth. So this is done here by this the system here. Let's take out the PCB and have a look. We should be able to do that. Hang on. Oh yeah, let's do that. See, with transistors and diodes, they're selecting the different resistors, and of course you see them trimmed for the perfect timing constant. So this is the resistor selector, you could call it that. And then the next module will be the capacitors. So this is actually the filter, and this filter is using those resistors for the settings. Let's look at the DC filters here. And of course, we have a low and a high part of the curve. So this is why you see 2 identical filters with the transistors here. I think we need probably to write a little bit in more detail how the circuit is, so it's going to be a little bit better documented. But at least you're going to get a really nice and smooth DC out of this box, so all the nice transitions. So we're going to generate really nice and smooth voices. Oh, come in here. So that is the idea of this unit, and it all repeats as many times as you got analog input voltages. So I hope all this works. That was a little bit difficult to take out the power supplies because we needed to take off this bottom plate. But now I just really need to document the different colors of this connector. Because what if one of these wires is going to fall off? So that will be the power supply I guess, is it this one or is it that one? This is something we need to investigate deeper, but see, if I move a little bit in those wires, one of them could easily fall off. So that will be the pull-up resistors. So this is an OR gated analog system for the pulses. And again, here we got all the pull-up resistors in this system. And yeah, okay, so this is the power supply for one of them, and it's kind of only powering. So what? So this is just powering the resistors, while this one is powering the entire circuits. So what are they living on? Those transistors probably just live on those signals. Aha, that is interesting. I look so much forward to make a little bit of a schematic, because this is a little bit confusing. Now I am home in the lab with the 4 power supplies, and there are actually a few things that strikes my eyes. Okay, one of them, number 1, is a TPS4, 24 volts, not a B or anything. So that is another model. Here we got a mains fuse. I guess this will be the mains fuse. They are all the same when it comes to number 1 and 2 here. That will be mains input. But what is number 3? I don't measure any connection on this to either chassis or to the 2 mains inputs. So it's not about that. So then we have all the output wires. I don't know if you can see this, but all those 6 connections here. I think, of course, I know this will be plus and this will be minus output. And then we got 2 others, and they're not connected on this model. Okay, so let's look at another one. So this is the one we call number 2. And this one is a model 4B. So it's a different model, and there's no mains fuse. And this is the same for all the others, number 3 and number 4. Okay, same model. So what we need to look at here is this. This is minus and this is positive. And see, pin 7 and 8, they're not connected. So power supply 3, same model, but now pins 7 and 8, they're connected. And again, this is minus and this is positive. Okay, so here's something funny. Power supply 4, same model, but now 7, 8, 9, 10, they're connected together, and that is minus. So what exactly is going on? I have measured all of them to deliver 24 volts. DC unloaded, okay, fantastic. I am not able to find any specifications online on this model or anything. So I don't know the specifications. I don't know how many amps, ripple levels or anything at all, what to expect. So we need to open them. And what I found so far is the 2 models here. They look actually different as well. So when I look from the side, look at that. So the lid is different. On this is the 4, just the TPS4, and that will be the 4B. So 4B models, they look a little bit different. And again, I always write numbers on stuff so I can put it back together, because there could be holes that's not matching or whatever. All right, I need to open and let's see what's inside and what have we got. Now they're all open, and I see a little bit of differences in all of them. It turns out this capacitor, see, is actually quite big in this one. And it turns out the serial number here is very low. So this is probably quite a lot older than the other. Also, the rectifier here is another brand. So let's look at the PCBs. also what I see is another funny thing about the diodes here. See, different brands. So I think that has also something to do with production dates and stuff like that. But other than that, they're very, very identical. Got a power resistor with a trimmer here. So I guess this is current limit adjustments. So I guess they all got exactly the same current adjustment. But what I see, yeah, now I know about this white wire. Look at that. It goes in here, but it goes to the shield. So there are actually two shields in this transformator. And one of them is that one with the white wires. See, the other end is connected to the transformator, but that is not connected to the chassis. Really? No, they lifted the transformator from the chassis. This is isolated, and this is done exactly in all of them. And if we look at the transformator, see, we got one shield and we got another shield as well. So they are really paying attention to shielding and all that kind of stuff in this. And that will be all the different voltages. We got all of them. They're using exactly the same transformator. So we got a 2.5 volt, 2.8 amps, 5.5 volt, 2.8 amps. And that is again 5.50 and then 5.5, 1.4 amp. And this repeats again. And then there's another one a very high voltage, 68 volts, 25 milliamps only. So, which one of those goes to this capacitor? And which one is going through the blue wires here? But we got blue wires here as well. We got blue wire. Okay, that'll be those two blue wires. But those numbers here, what is what? I think it's easier for me to just to measure. Oh yeah, I was looking at the different boards, and what do I find? Leaked capacitors. Look at that. I think both of these puked a little bit. We can see the snisky here. And let's look up here. No, that one is not that bad. Only a little bit. Yeah, look at that. Look at this one. See, we got leak here. And not in that one. Those don't look leaked that much. Only a little bit from that one. And again, this one is not so bad. But anyway, they're all 50 years old. And I think if I need to get any kind of quality out of this machine, I really need to replace them. See, this capacitor is also leaked, and that is the main rectifier capacitor. Oh yeah, this is a 3055, and that is the same in all of them. 2N 3055. So that is a 60 volt transistor. So how much, this is 24 volts output, right? So how much is actually on this capacitor? I can't wait to see that. But they all deliver 24 volts of DC unloaded. I didn't check Ripple yet, but that is going to happen in a minute. You can say what you want. This power supply with all the leaked capacitors and I don't know what not. This is a step response, 20 millivolts per division. So this is 1 amp, 0 to 1 amp, and then the voltage just drops like this, choop choop, and then it goes nice and stable. See, I can do it again. Doing 1 amp. And here's what happens if I go into amps and give, so this is 1 amp, and doing, turns off. Here we go. Then it turns off. So then I go off and on again. Nope. See? So there's a fallback. So that is quite smart. And right now 1.2 amps, so this is 29 watts of output. Let's look. So that's almost 60 watts of input. So that means this one is burning 30 watts. How is that going to happen? And this little heatsink in here, if we look real carefully, where is it? Tiny little. This is going to be hot. So here on the main charge capacitor, we got 44 volts unloaded and 37 volts loaded with 1.2 amps. So then you can easily do the calculations, how much is lost in the series regulator, and that means the rest is in the transformator. So that is about 50% efficiency, quite normal for a linear regulated power supply. I would probably have put the voltage closer so that we're not losing that much. Could have been 60, 70% actually. It can be a lot higher because this is a fixed output voltage. Phew, that was real easy. Just to unsolder a few wires in here. That one, and there is another one in here. Where the heck is that one? That one is difficult to see. There's a little red one here, and then those wires here at the bottom. Then I can bend up the PCB and then change all the capacitors. Fantastic. Also, I measured some of the capacitors when I took them out. I want to share this little detail with you. So look at this one. Let's see if I can do this with one hand. Maybe I need a little bit of luck. Nanofarad. Really? And this capacitor should be 50 microfarad, 70 volts. Yeah. And if I take some of the others, they're actually not that far away. But one here is just completely gone. That is not good. And you can't really see it. It doesn't look that much worse than the others. But this is what happens. And there's like 1500 microfarads left in this one. And probably also quite a high internal resistance. Just found those. Got a little stack of this. They're a little bit too much, but hey, look at this tiny little size. And it's the same diameter, so it will fit in here, right? You really gotta see this. I'm so sorry I don't have a schematic of this power supply. Oh man, but this is really getting funny. So those tiny little black dots that I put on the capacitors, that is the same as 0 volts relative to the output. Okay, so I put the black wire on my voltmeter to output 0, and then I measure the output voltage like this. Okay, 25.2. Oh yeah, 24.2. Okay, fantastic. Let's try and see something funny. So this capacitor it's positive here, and this is the output. See? Now let's see something funny. A negative 50 volts. Isn't that something? This capacitor here. This one is, of course, our output voltage. But look at that one. and negative 96 volts. What is the use for that? Again, here's a capacitor. This is our 0. And here, a plus 92 volts. What is the use for that? Here is a plus 13. And this is 0 again. So this capacitor got 0 here. So here, 24.2. So this is our output voltage. So isn't this just really weird? Why are we having all those negative, a minus 50 and a minus almost 100? And then also another positive, this crazy. I mean, why? On the main capacitor, main filter capacitor we got here, we got plus 44 volts. I don't know. I would really love to see a schematic of this thing. Now, meanwhile, I figured this out. Of course, the white one here is the screen in the transformator. Blue, number 7, that's chassis. And then there's another screen in the transformator for the secondary sides. And then the rest is easy. So that is how it is. Now I have documented how those things works. And this is the number 3 power supply. Voltage output at 0 to 1 amp load. And you see some ripple as well. And I think this is because the output capacitor is not as big as it should be. But again, this is only 20 millivolts per division. Okay, so it's really not that bad. See, oops. Got a little bit of a good connection here. Yep. This is just crap. Since I'm playing around with the different capacitors at the moment and changing the capacitors, of course I'm reading real careful the values and the ratings. In this one, I measure 99 volts on this capacitor, and it says 100. 96 volts on this one, it says 100. Also see, this is a much higher serial number. Here we got 25 microfarad. In the previous, much lower serial number, only 10. So they improved something. So I think we're going to stick with the values from the one with the higher serial number. That's probably better. Did I also show you guys this? I think I forgot it. I took out the PCB here and now I'm starting to play with the capacitors. But see, there's no bleeder resistor, no discharge resistor over the main capacitor. So you could get into a lot of problems when you're soldering around here and if you didn't carefully discharge this capacitor. And of course you can't short circuit, it's going to go spark. Okay, so be careful about this. So how is it on that one? Okay, that was the one with the hundreds of volts. All the others are not dangerous anymore. Oh, by the way, did I show you guys this NTC? Temperature compensation. That is nice. And by the way, this is a 40 volt zener, 15 volts positive zener, and 15 volts negative. So that was a few hours later. Some of them like 1 out of 5, completely random. They got only a few nanofarads in them. It's amazing they actually worked quite good, those power supplies, with really low capacity in some of them. But look at that. One of the main capacitors is a 35mm type. How annoying is that? And the capacitors I got for this, they're 30mm. I can't say I'm super proud of this solution, but hey, if it works, it works, and say no more. Thank you. Done and labeled and fine adjusted to the last millivolt. Now we're ready to go install and ready for the next chapter.